Hello, friends. I'm Dr. Miller, math magician. I would like to teach you how to learn math and how to learn programming and how programming can help you learn math. And we're going to use the square root function in order to illustrate that. So let us begin. Not to go through all the words in here, but let me summarize with the last statement. Programming is a language to help us better communicate our understanding of mathematics. As I mentioned, we were going to use the square root function to illustrate how we learn mathematics and how we can learn programming. In this case, I would like to develop what's called recursion formula for finding the square root of a number, one of many techniques that we can use. So we start off with the equation x squared equals a. Then when x is equal to the square root of a, this equation will be satisfied. So I now add x squared to both sides. And then I divide this equation by 2x, which leaves me with this. And then using the fractions and commutative property, I get the equation reduced to this simple form. And what I'm going to do is start off with a value of 3. And I'm going to be using 2 as my number that I would like to find the square root of. And when I put that value of 3 to start with, that will give me some value closer to the square root of 3 than 2. And I will continue this process of putting the answer back in until I get the right answer. And I've discovered by experience that after doing this 6 times, starting off with the proper C, this will work for the numbers between 1 and 100. So let's now see how we go about doing this. Okay, so now taking our recursion formula. Here's our 2 for which number we're finding the square root of 3. When I put that in for the first time, I get 1.8, which is closer to the square root of 2, but it's only good to 1 digit. So I only carry those first 2 digits. And when I put that in, I get something that's now closer than 2 digits. So I don't have to do all that long division. I then put that back in, and I notice that my answer keeps getting better in terms of twice as many digits. And I continue this process for 6 times, and after that, I get my answer good to approximately 15 places. Okay, and now what I'd like to do is check that code. So I now expand the code. I put a print statement in there to print out what's happening, and I put the square root of 2 as my sample. And when I go through, I see that I get numbers that are close to what I had before, 1.8, 1.46, 1.414. We look back, and we can see that. So the computer is, in this case, giving me answers consistent with my hand calculations. But over here, the first guess is not particularly good. It's coming out with 1.5. And the reason for this, there's something in the computers that can be explained mathematically, is the computer has what they call integer and floating point arithmetic. Integer, the results can only be an integer. So if I divide, say, 2 by 3, 0 is the closest integer can get. However, when I multiplied the 3 by 0.5, 0.5 was floating point that overtook. So after that, everything was done in floating point arithmetic. And so these are one of the things I have to be very careful about in terms of using the computer arithmetic, which basically I can explain mathematically. And if I can only get to 15 places in the computer, I can't get the answer better than that. Now, I want to try this for more than just the number 2. And I also want to format it. One of my formats is going to have 14 decimal places, and the other is going to have 16 decimal places. With the integer being the integer part of the answer being the 15th digit. And when I do this, I now will write out my answer, a format statement, and I'm checking my work. I square this because that should give me the right answer. So I'm letting the computer do the checking for me. And when I do this, I find two interesting things. Well, first, when I do it with just asking for the answer to 15 places, I get the exact answer for all of those numbers. But when I let it go out more digits, I see that the computer can't handle it and doesn't give me the right answer precisely. It gives me the right answer approximately. So this gives me a feel for a little bit about the oddities of the computer and understanding the mathematics to apply to that. Now, I would discover if my numbers were outside of 100 or less than 1, that the starting seed of 3 won't work very well. And it would take me a lot more iterations. So I have to find some way of getting my numbers between 1 and 100. Like make use of the mathematics that when I raise a number to a power, I raise each of these numbers to a power. So I get the square root of a, and the square root of 100 is 10. And if I divide by 100, square root of 1 over 100 is 1 over 10. So basically, after I've gotten my numbers between 1 and 10, I'm counting the number of times that I had to divide by 100 in terms of multiplying by 10. And then I either divide or multiply the answer, depending upon what the instruction was here. So the switch here, when set to 1, says if it's 1, then that means that I have to divide in order to get the right answer. If it's not, then I multiply. So now we have our full code taking care of the anomalies. As you can see, this would be overwhelming if we had to do this all in one shot. But if we take a look, let's make use of the special features that we have here. Initially, I started off with this formula. And then when I wrote the code, I expanded it to go this far. And then I had a little bit of a problem, so I took another piece of code. And now that made it manageable. This piece and this piece, I could understand easily. And so now you can see that represents a major part of the code that I was working with. Now, one of the difficulties of going through all of that is, if I asked how many of you followed that, unless you knew this material already, you would have said, yeah, I saw what you were doing. But now I need to go back over it again, now that you see the direction to go, in order for you to be able to fully understand this. So let's now go back and see how that works. So this is where we left off with all of the code. So let's now go back, now that we know what direction we're going. We know that we have to have some algorithm for generating the answers, and we know that we need to find a way of doing this as quickly and simply as possible. So what we found is that the algorithm works well with this seed for numbers between 1 and 100, but beyond that, it doesn't work as well. So we now find a way of bringing those numbers within that range and then correcting for that. So now let's go back to see what we were looking at before. Okay, so here we started. We had to find a recursive operation for which we could find the square root. So this was the mathematics we did to get that recursive operation. Then when we programmed it, we used a statement in the language, a while statement, which says, do this over and over again until we've done this 6 times. What we've done is we've started our counter off at 0, and each time we add 1, we increment the number. So on the 6th time, it starts off at 0 instead of 1, so when we get to the number 6, that's actually 6 times, and 6 is not less than 6, so it will drop outside of the loop. Colon is basically use what I call a branch statement. Okay, then we found the importance of checking out the information numerically so that we can find a way to check that the computer was doing it correctly. And in this case, we took our code and we inserted a print statement. which then would allow us to see what was happening. Now, we really don't want this print statement in there all the time because we don't want to check it, but it basically was a way of getting our code started. And in order to make this work, we had to define this as a function. So this is DEF, define a function. And the function is a branch. And so I put a colon there. And then the rule is after a branch, we have to indent 4 spaces. Again, you'll notice we indented here because of the font, it doesn't look like 4 spaces. And then we see that once we are finished the loop, we have to indent back out again. And then indent out again has now ended the loop for our subroutine. Okay, then we found that when we looked at this, that we had to be a little bit careful about our numbers, that the computer could use different kinds of arithmetic, and there were techniques that we had to use in order to get that. So I could always ensure in my square routine, if I multiplied whatever the number comes in by floating point 1, that I would then get it into a floating point format. I also discovered that a computer is only good to a certain number of digits, so even though I got 49 for my answer, which was close, I was off by 1 digit. Okay, then we now expanded our code, and the major difference that we had in here was 2 things. One, most important, is we let the computer check. Okay? And we could do this more sophisticatedly, but this basically tells us how to check. And the format basically was telling us how accurate our answer. We could check the precision of our answer rather than let the computer decide how many digits it would keep for us. So this now printed out our code, and again we looked through it and checked. We could also have other code that would check this so we wouldn't have to do this, and we could do this with thousands of numbers to check the computer. Okay, and then we found that we wanted to improve the code, and so we then looked at a small segment that could correct this. And by looking at it this way, we're not overwhelmed with as much information. So we broke this up into 2 parts, the part that basically converted the number between 1 and 100, and the part which actually then made use of that correction. And then finally, we have our full set of code. So what might have looked like an incomprehensible problem now has become something that's easier to handle. And so basically, by looking at this video several times over, you can begin to pick up some of the finer points, or more finer points, than I had shown you already. And this is basically the technique that a good mathematician uses to learn his math. Computers tend to formalize a little bit more and makes it easier for those who don't have the same skill or the programming skills to do this. Thank you very much. I hope you enjoyed it. Hope you